Example number 29. Solve the logarithmic equation 3 log 2 to base x plus log x to base 2 is equals to 4, isn't it? We dealt with this kind of cases when you toggle. We say when you have log b to base a to be equals to y, then it means log a to base b is 1 over y. Because you cannot use the laws of logarithm saying that they are different bases. So you see, this is log 2 to base x, this is log x to base 2. But if you have log b to base a, that is y, then it means log a to base b is 1 over y, isn't it? So what do you do here? You let y to be equals to log 2 to base x, isn't it? Then that will imply that 1 over y is log x to base 2. We proved that, isn't it? Are we together? So it means where you have log 2 to base x, you put y, and where you have log x to base 2, you put 1 over y. So we have 3y plus 1 over y to be equals to 4, isn't it? So you now get rid of the denominator, isn't it? How do you get rid of the y denominator? Meaning you multiply both sides of the equation by y, isn't it? So here you get y times 3y, you get 3y squared plus y cancels with y, you remain with 1. Then on the other side of the equation you have 4y. Are we together? So if you bring 4y this side, you have 3y squared minus 4y plus 1 is equals to 0, isn't it? See, that is quadratic. You check if factorization is working, you use factorization. If factorization does not work, you go to quadratic formula, isn't it? A product of 3 and a sum of negative 4, negative 3 and negative 1, isn't it? So it means to solve this, we have 3y squared minus 4y is the same as minus 3y minus y plus 1 is equals to 0 by factorization, isn't it? Then from there, 3y is a common factor. Here you remain with y minus 1. Then negative 1 is a common factor. You remain with y minus 1 is equals to 0. Negative into negative, you go back to your positive, isn't it? So we have 3y minus 1 into y minus 1 is equals to 0. So you can see it is either 3y minus 1 to be 0 or y minus 1 to be equals to 0. So this implies here y is 1 over 3. If you take 1 the other side, then you divide by 3, isn't it? And this one implies y is 1, isn't it? Then you substitute back the value of y. What is y? What did you let y to be? Log 2 to base? Meaning where there is y, you put log 2 to base x. So it means log 2 to base x is equals to 1 over 3, isn't it? So what is x? X is the base. So you put x is the base, then 2 is the corresponding number, a third is the index, meaning x raised to power a third is equals to 2. The index is the log of the corresponding number to a given base. Or the other way to solve it, when you have this, you simply introduce log x to base x so that you have the same base, isn't it? A log of a number to the same base is 1, isn't it? Then this a third becomes the power. The coefficient becomes the power, isn't it? Then you ignore logs on both sides of the equation. You remain with the 2 is equals to x raised to power. Are we together? Then the second case where there is y, you put 1, you have log 2 to base x. Where there is y, you put log 2 to base x, I mean, is equals to 1. So what is x? X is the base, isn't it? 2 is the corresponding number. 1 is the index of the power, isn't it? So x, this implies x is the base. 2 is the corresponding number, 1 is the index. So x raised to power 1 is 1. So it means x is 1 or x raised to power third is 2. Isn't it? So what is x? So you find that you multiply either side of the equation by 3, isn't it? Isn't it? The first case there you found x raised to power third is equals to 2. So you multiply either side of the equation to power 3. So that this you remain with x is 2 raised to power 3, meaning x is equals to 8. Isn't it? Then the second case there you found direct x is equals to 1. So the value of x is either 8 or 1. Are we together? Good.